Okay, as you jump into preparing for the Proctored exam, I thought I'd show you some of the topics, a couple of them that, students struggle with or they often miss just from the quarter so far. Okay, the first one is looking at something in this factored form, and one of the skills we'll practice a little bit later on is factoring, but we want to make sure we understand what the x-intercepts are here. So the x-intercepts is this equation on the opposite of what you see in there. So you've got a -3, 0, as well as the opposite of x plus 1 is a -1. And the reason why that's happening is because you're actually setting these equal to 0, right? Because your y value is 0 when you've got an x-intercept. So when you move on to the other side, you get a -1. The axis of symmetry, if you think about plotting these 2 points on your graph, we're going to graph in a minute anyway, the axis of symmetry has to be right in the middle of those two. So think about the average of -3 and a -1 is -4/2, so it's a -2. So your axis of symmetry is x equals -2. Okay, if we want to write the equation then in standard form, we're going to have to multiply this out. So let's start by multiplying x plus 3 times x plus 1. When we multiply this, and then I'm going to add the 2 in at the end, I think we're used to seeing it kind of like in that box model where you're thinking about literally multiplying your x plus the 3 little ones, and what do we end up getting? We end up getting an x squared, a 3x, oops, sorry, that needs to be a 1 down there. X squared, a 3x, a 1x, and a 3. So when we combine that all together, we get x squared plus 4x plus 3. You can also think about distributing and multiplying each term individually. And that's what we're going to have to end up doing with the 2, is we're going to have to multiply that 2 in. So we end up getting y equals 2x squared plus 8x plus 6. Okay, to get vertex form, there's a couple different ways you can do it, but I almost would start with like, hey, what is your vertex? So our vertex goes along with the axis of symmetry, so we know it's a -2, but what happens when you plug -2 into your equation for x? Let's see. So here we get 2 times 1 times a -1, so we end up with a -2. So the vertex is actually at, so -2, -2. So it's right here. Doesn't always end up being at the same point. If you know that, I actually think one of the easiest ways to then write vertex form, let's take a look, vertex form is y equals a x minus h squared plus k. And h and k are the center. So when I think about plugging in my vertex, I'm doing x minus a -2. That's really x plus 2 squared, and then minus 2 at the end. This a at the beginning is the same a from up here, so it's this number out front, which is a 2. I kind of feel like that's the easiest way to go about it, but you can also do, think about that area model where you're completing the square, right? In this case, how many x squareds do we have? We have 2x squareds, right? We have, 8 pieces together, so we're putting, 2 on each side here. It looks something like this. Then you're thinking about how many squares completed. We have 4 squares completed, but we only have 1, 2, 3, 4, 5, 6 ones, so we need these 2 more, so that's why we have you're borrowing 2. So that's why we have the -2 at the end. Remember these side lengths are x plus 2, so x plus 2 squared. Okay, now we have enough to go ahead and graph the equation. And if you want to think about it, this a good thing to think about that is that's actually telling you that it has like a stretch factor of 2. Okay, if you get stuck with something like graphing, I want to remind you that you can use your graphing calculator to kind of double check things. If you don't have access to a graphing calculator, Desmos is great. That's such that when you type things in, you should be able to check some of these, right? Those are your x-intercepts. That's your vertex, what we thought. The cool thing, too, about the y-intercept, it's 6, and notice that matches the end of your standard form right there. So there's ways to kind of look at the equation, too, and notice some of those features. Okay, let's look at the table below and determine what type of sequence it is. So we got to decide, are we adding, are we multiplying? Is there maybe a same first difference, same second difference? In this case, it looks like even if you thought it was adding 10, when you do 20 plus 10, we're not getting 40, so we're multiplying by 2. So therefore, this is an exponential type of equation. And that's because it has the same ratio of 2, right? It's multiplying here. So when I go to write an explicit equation, f of x, let me remind you, and you do have a formula sheet for this, but f of x equals f of 1 times r to the x minus 1. So our formula is f of x equals, our first term is 10, times our ratio is 2 to the x minus 1. Okay, we're into factoring now. We're looking for things that multiply to 5, two numbers that multiply to 5 and add to 6. So what are my two numbers? My two numbers are 6 and 1. So at that stage, you write x plus 6, x plus 1. Okay, we're looking for things that multiply to negative 15 and add to negative 2. So we got negative 5 and 3. So my factored form is x minus 5, x plus 3. This one you could do a similar thing. You could say it's multiplying to negative 16. There's nothing in the middle, so you get like a negative 4 and a 4. Or think about like the difference of squares, right? So the square root of x squared is x. The square root of 16 is 4. So you get x minus 4, x plus 4. And then we look at this last one. We're going to multiply 2 times negative 18, we get negative 36, adding to 9. So I think that's like a 3 and a 12. If we want to be a positive 9, we're going to have a negative 3. And I think what you guys have seen the most is probably just dividing by 2 there. So this factor on the left side becomes 2x minus 3. And sometimes you may even see it written like this first, and we're going to move then that 2 out front so we don't have that fraction. And then this one, it simplifies to 6, so the other factor is x plus 6. You do need to have it in this second format. That first format's not acceptable because you're not going to end up getting 2x squared when you go back through and multiply it. Okay. After finishing his math test and he flings his math book towards the top of the building, he has quite an arm. The book's height is measured in h of t in feet, and in time in seconds is given by this function. What's the maximum height? When does it happen? Okay, if you want to deal with the maximum height, there's two ways to do it. If you're calculating it algebraically, you use like the negative b over 2a. So this is your b, this is your a. You're doing negative 50 over 2 times negative 16. Maybe use your calculator a little bit. So we have negative 50 divided by negative 32. And we end up getting just like this fraction. It doesn't end up super nice, 25/16. That's the time it happens. So what time does it happen? It happens at 25/16. I think they actually like the decimal a little better. So 1.5625 seconds. But the height at which it's happening happens when I plug in this into my equation. So negative 16 times 25 over 16 squared plus 50 over 25/16 plus 100. Good thing you've got a calculator now, right? I'll show you one other way you can do it in just a second here. But go ahead and type things into your calculator, or you could use decimals if you don't have one. I end up with, I'll do 139.0625, and that's how tall it is. So it happens at this time, and this is the maximum height. Okay, let's say you're like, oh my goodness, I have no idea what's going on here. This is where I'd say decimals comes in handy. You got to be a little bit careful, though. I'll show you kind of two different ways you can do it. If you start typing it in with t squared and then do like the plus 50t and then plus 100, it's not going to graph it for you. So you've got two options. If you include the beginning part where it has like the h of t and then do equals, it then knows you're using t as your variable, and you should be able to graph it. You'll kind of see that parabola. Your other option is, as you go through, just use x rather than the t. Okay? Oh, and I forgot a 0 there. Sorry about that before. Okay. So I'm going to kind of just sketch it. They're going to ask in a moment like what the y-intercept is. The y-intercept is 0, 100. I'll just kind of mark some of these. The vertex here, right? We already kind of found that. That's the maximum height, right? It's the tallest. 1.53, sorry, 1.1 1.563 and 139.603. Hey, notice that's exactly what they were asking in A. They were asking basically what the vertex is, and then the x-intercepts. We technically have two of them, although I'll talk in a minute why we really only care about one of them. So let me label both of those. Negative 1.386, I believe it was. Yep, comma 0. And then also 4.511, comma 0. Okay, perfect. So let's talk about just what's going on here on the graph. So if this is time, right, and this is height, think about this book traveling, right? He throws it up and it kind of comes down. This then is where it starts. This is like the maximum, right? And then this is when it hits, if there's 0 height, it's hitting the ground. So when they ask you when does it touch the ground, they're really asking what the x-intercept is. We don't care about negative time, right, because we're not going back in time. Time starts when he throws the book. But it hits the ground at 4.511 seconds. And you could do things now, too. Like if they ever asked you to put it in a vertex form, you can take that vertex, write the coefficient of negative 16 out front, and then do like your x minus the negative 1.5 squared plus the 139 at the end. Okay, last but not least, let's look at what's going on in this pattern here. This pattern here, you're looking at it like, okay, I'm not multiplying to get to 1 because that'd be like negative 1/2. So let's see what happens when we start adding it. I'm going to make sure my table is nice and clear here. Okay, to get from negative 2 to 1, I'm adding, let me see if I can make that look better. There you go, 3. To get from here to here, I'm adding 5. I'm adding 7, and then I'm adding 9. Okay, so it's not linear, right? It's not multiplying, so not exponential. So it's got to be quadratic. The reason why it's quadratic is we're adding a linear equation, right, for your first difference, but then we have the same second difference is the characteristics of a quadratic. So let's see what they mean by that. They're saying, hey, to get from here to here, you add 2, you add 2, you add 2. So I'm going to just go, actually, I'll pause for a second. Okay, so let's write an explicit equation to start with. Okay, so that's like your f of x equals ax squared plus bx plus c. Okay, some of these are easier than others to find. So the ax squared is the second difference, which is 2 divided by 2. So I'll call that 1 in just a second there. So we're going to have like 1x squared. Okay. We're going to have to find what b is in just a moment here, but plus c. C is the 0 term of the first difference, the quadratic equation, sorry. So if I go back in time here, this is going to be when I go like 2, what plus 2 is 3, 1 plus 2 is 3. So then think about this. You're basically saying like, hey, what plus 1 is negative 2? That's a negative 3. I could keep going back more, and I could say, not that we need it right now, but like if I go back again, I'm saying what plus 2 is 1? Negative 1 plus 2 is 1. Okay, right now though, we need this negative 3. Maybe I'll highlight it in a different color just to make it a little clearer. Oh, sorry, change the color of everything. So this is a negative 3 that we have at the end here. Okay, so now we just got to double check what this value of b is. And so I usually use the plugging in 1. So when I plug in 1, so I have like 1 squared plus b times 1 minus 3. I want this to equal what's f of 1, right? When you plug in 1, you get negative 2. So here you get 1 plus b minus 3. So you get negative 2 equals negative 2 plus b. So b does equal 0. So we don't end up having a b, because if this is 0, right, then there's nothing there. Okay, so when we ask for your explicit equation, we end up just getting f of x. You can write 1x squared, or you can just write, or like f of x equals x squared minus 3. Okay. Next thing, when we write the recursive, it will usually give you that f of 1 equals negative 2, like what the first term is. But then we'll have to write this next equation. F of x equals f of x, f of x minus 1, plus m, they say is the second difference, x, and then plus b is the 0 term, right, what we found right here of the first difference, so -1. All right, that's it. Good luck studying.